Thank you, Ethan. Okay, ideally everybody has a worksheet in front of them. It looks vaguely like what's on the board. I see people writing their name on it. That's a good place to start. You'll notice at the top, we see those trig ratios from Tuesday. Definition for sine, definition for cosine, definition for tangent in terms of a right triangle. SOHCAHTOA. In addition to those three, there are three more trig functions that we commonly see in math and science. And those three trig functions are the reciprocals of the ones we saw on Tuesday. Cosecant, secant, cotangent. And before we look at the definitions for secant, cosecant, and cotangent, we're going to review some vocab. Raise your hand if you remember what reciprocal means. And I see people doing this. I see a hand from Ethan. I see a hand from Marissa. Ethan, what are you thinking? When you flip it, Marissa's nodding her head. Good. You take a fraction, you flip it upside down. And we typically write that as 1 over the thing we want to flip. Good. We are going to be very specific here. When you see reciprocal, that means flip. So the reciprocal of sine is 1 over sine. And we are writing that out because there is something that looks similar that is not, that we are going to see in our next unit. And that is the idea of an inverse trig function. And the question is, what does an inverse function do? And we haven't seen that since the middle of last semester when we had trig together. When I want to find an inverse function, I switch the role of x and y. I would take the graph of the sine function and I'd change the x and y axes around, flipping the graph on its side. And we practice that with things like parabolas and other shapes in pre-calculus. This semester, we're going to do that same thing with trig functions. It is important to note, when we write inverses of trig functions, we are going to write sine to the minus 1. That is the inverse function for sine. At some point in Math 1 or Math 2, you probably learned about negative exponents. And I'm guessing when they taught you about negative exponents, you learned that x to the minus 1 means 1 over x. Normally, when you see a negative exponent, it means bring it down to the other side of the fraction bar. With trig functions, that is not what that notation means. For trig functions, sine to the minus 1 means the inverse function for sine does not mean 1 over sine, the reciprocal. Those are different things. Everywhere else in math, that works. But for trig functions, we use different names for the reciprocals versus the inverse, because I don't really have another nice way to write the inverse function for sine. So that is taking x and y and switching them. This is taking sine and flipping it upside down. different things. Yeah? Okay. This we're going to come back to later. This is our next unit. Reciprocals are what we're going to do now. If I could get my pen to work. So no inverses in unit 1, only reciprocals. 1 overs, 1 overs. Yeah? Okay. Questions about those vocabulary words before we look at the reciprocals? No. Okay. We'll come back this way. So each of our original trig functions, sine, cos, tan, get a reciprocal. So cosecant is our first, and that's 1 over sine. It's a reciprocal of sine. Sine is opposite over hypotenuse. What do we think cosecant is? Exactly. Take the fraction and flip it. So this is hypotenuse over opposite leg. Take the sine function, opposite over hypotenuse, flip it upside down. Yeah? Reciprocal means take the original fraction, flip it.
So then that will also be backwards.
So good, Bruno. Could you tell me what goes in the numerator for secant? What goes on top?
On top would be hypotenuse and bottom would be adjacent.
Very good. And our last one, Ellie, what would cotangent look like? Reciprocal of tangent. You're not sure. So remember that reciprocal means take the tangent fraction and flip it upside down. Exactly. Good. Perfect. Looking at those new fractions, the definition for cosecant, secant, cotangent, it's the same 3 sides of the right triangle that we used for the original trig functions, just upside down. So if you are asked to find a cosecant, a secant, or a cotangent, you start the same way. Circle the angle, label the opposite side, label the hypotenuse, label the adjacent. Plug the numbers in where they go. Yeah. Good. Before we do some, mathematicians are lazy. We're not going to write those names out. So cosecant gets shortened to CSC. Because we are lazy. Secant gets shortened to SEC. Anyone have a guess for what cotangent becomes? Yep, cot, C-O-T. Very good. It is important to note that cosecant goes with sine, not with cosine. It took me a very long time to remember that because it doesn't make sense in your head.
Yeah,
Why?
I
I agree. Blame the Greeks. They did it. But we are stuck with that naming convention. So the reciprocal of sine is cosecant. The reciprocal of cosine is secant. It is opposite what you think it should be. We are going to practice setting up the originals and the news for a right triangle, and then we're going to look at how to simplify. Yeah? Before we do that, questions on definitions and notation. No. It's one of those things you just kind of have to remember. There's no easy way around it. Okay, so we have a right triangle, ABC. We're given two legs of the triangle, 2 and 4. We don't know the hypotenuse. We are asked to write all 6 trig functions for each of the angles, angle A, angle C. So we will start with angle A. I'm going to do these guys in red. I'm going to circle my angle of interest. Alex, can you tell me which side of that triangle is my hypotenuse? Very good. 1 across from 90. So side AC. Very good. Jordan, where is my opposite side? Very good. That's the guy across from angle A, which means this guy's my adjacent. And those labels in red only apply to the trig functions of angle A. If I'm looking at angle C, those labels are going to flip. Yes, Bruno. A question on what? How what? What is the hypotenuse? Oh, you're adding. There's something you have to do before you add. We have to square, then we add. So what is 2 times 2? 4 plus 4 times 4? 4 times 4, sorry. 16. Good. And I'm pretty sure that's 20. Yeah? I see some nodding. And I know to undo a square, I take a square root. So that hypotenuse is square root of 20. I am not going to leave it like that. You can't, but you can simplify it. Yes, 20 is divisible by 4. 4 is a perfect square. What does it mean for a number to be a perfect square? We have an example. 4 is a perfect square. You can't define it. Can somebody give me another example of a number that is a perfect square? 9 is a perfect square. Another one? 16 is a perfect square. 25 is a perfect square. 36 is a perfect square. They keep going. What do those numbers have in common? Where are they coming from? There's a pattern with those numbers. I'm going to give you just a minute. Check with your neighbors. Ooh, yeah, it's a number squared. This is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. What happens when I take the square root of a square? It cancels, yeah, right? The square and the square root on the C just left me with C. The square of a square root is going to cancel. So square root of 4 is going to be 2. Square root of 9 is going to be 3. Square root of 16 is going to be 4. It's undoing the square. What I want to do is for every number that's under a square root, I want to check if it has a perfect square factor. Is it divisible by a perfect square? And I see 1 or 2 heads nodding. 20 is divisible by 4. So I am going to rewrite 20 as 4 times what? 5. 4 times 5 is 20. Good. I cannot take the square root of 5. 5 is a prime. Yeah? Can't do anything with that. But I can take the square root of 4 and pull that answer out in front. Because this is the same as square root of 4 times square root of 5. If I'm multiplying under a square root, I can separate it into 2 separate square roots. What is the square root of 4? 2. 2. So this is 2 root 5. That is the number I'm going to use anytime I am asked for the hypotenuse of my right triangle. Not root 20 to root 5.
Okay.
And yes, that is ugly. That is why we are practicing. Practice is how we get better, yeah? We practice together.
So that's it. We're done.
We're set up. We can start writing our trig functions now. So I'm going to do the trig functions for A, and then I'm going to give you a minute to do the trig functions for C. So for angle A, sine is opposite over hypotenuse, which would be 2 over 2 root 5. Did I do that correctly? Yeah? I see nodding. Good. Cosine should be adjacent over hypotenuse. And tangent should be opposite over adjacent. And now we have the fun part. I know that the next 3 trig functions are reciprocals of the first 3. I know if I take the sine fraction and flip it upside down, I get cosecant. If I take the cosine fraction and I flip it upside down, I get secant. If I take the tangent function and flip it upside down, I get cotangent. So I don't need to even look at my right triangle. I just need to take those fractions and flip them. So 2 root 2, or 2 root 5 over 2, 2 root 5 over 4, and 4 over 2. And somebody should check, did I do that correctly? I see some nodding. Yes. Before I set you loose on angle C, same concept, those answers up there would probably get marked wrong by a computer. The question is why? And I see 2 problems. Yeah, we got to simplify 2 things. First, some of those numbers cross-cancel. They reduce. Because I've got a whole bunch of evens, right? 2 and 2 are going to become a 1 and a 1. 2 and 4 are going to become a 1 and a 2. 2 and 4 become a 1 and a 2. 2 and 2, 1 and 1. 2 and 4, 1 and 2. 4 and 2, 2 and 1. So right off the bat, some of those get a whole lot prettier. Tangent is 1/2. Cotangent is 2. 2 divided by 1 is 2. You will notice I didn't copy all of those over. These are fine. Root 5 over 1 is root 5. Root 5 over 2 is fine. Sine and cosine would still be marked wrong even though we have reduced those numbers. Why? Yes, very good. We talked about it in our bell ringer today. Square root in the denominator makes us unhappy. The question is, how do we as mathematicians fix it? And the answer is the only thing I'm allowed to do to fractions and not change them is multiply by 1. Any number times 1 is itself. So I'm going to multiply the top and bottom of that fraction by the same number, because that's the same as multiplying by 1. Specifically, I'm going to multiply it by the square root. And when I did this yesterday with my 4th period, everybody said, but don't square root on bottom and square root on top cancel. The answer is technically yes, but that's not helpful. I don't want them to cancel. I want to multiply. So in your small groups, turn and talk. What is square root 5 times square root 5? Give you about 60 seconds. Anything times itself is a square. What happens when I square a square root? It cancels. This becomes a nice, pretty integer. That gets rid of the radical in the bottom, which is okay. I'm allowed to have a root 5 on top. I'm just not allowed to have it on bottom. Root 5 over 5. I can do the next one without really doing any math. The next one had a 2 on top, which will still be there. Root 5 over 5. Yeah, because we canceled that common factor first. That is a big idea, right? There was a lot of high-level nitty-gritty stuff there. So what I'd like you to do is take a couple minutes in your small group, repeat that process for angle C in the same triangle. Yeah? So repeat that process for these trig functions here. I'm going to put a couple minutes on the clock, and then I'm going to have you guys walk me through how that works. Yeah? Okay, so let's tackle angle C in that same triangle. When I saw you on Tuesday, and we focused on the first 3 trig functions, sine, cos, and tan, we learned that there was a pattern in the trig functions for angle A and C when I go from one angle in the right triangle to the other angle in the right triangle. So can anybody tell me what happens to sine and cosine when I go from angle A to angle C? They switch places. Yeah, we learned that sine of A is cosine of C, cosine of A is sine of C. And since I've already reduced those, why would I set them up and reduce again? I'm lazy. So sine of A becomes cosine of C. Cosine of A becomes sine of C. Mathematicians are lazy, right? We don't want to do more work than we have to. If we recognize patterns, we don't have to redo all of that simplification. Good. Who can tell me what happens to my tangent function when I go from angle A to angle C? It flips. Good. Because when I go from angle A to angle C, the labels opposite and adjacent flip. Good. So 1/2 becomes 2 over 1, which is 2. Yeah. Perfect. And then the next question is what happens to these guys here? So there's 2 ways to get to them. The first is we just learned that cosecant is 1 over sine. I take sine, I flip it. So I could take my sine fraction to root 5 over 5 and flip it. But that's going to put a root 5 in the bottom. Frowny face. What I can do is take the original sine fraction, 1 over root 5, and flip it. But the other thing that I know that's going to happen is that cosecant, secant, cotangent follow the same pattern that sine, cosine, and tangent do. Cosecant of A becomes secant of C. Secant of A becomes cosecant of C. Cotangent of A, flip it to get cotangent of C. For the same reason, those labels opposite and adjacent flip positions. So root 5 was cosecant for A. It's going to be secant for C. Root 5 over 2 was secant for A. He's going to be cosecant for B. What about cotangent for C? 1/2. 2 over 1 flips to become 1/2. Yeah. Yeah.
It's confusing, but I guess
It's simple if you can remember the pattern. The trick is remembering, and we know we remember through repetition and practice. Yeah? So we're going to take a deep breath. You will notice on the back side of that notes, there are just some practice problems. We're going to do the first one together, and then I'm going to give you some class time to do numbers 2 through 6. Or 2 through 8. I can't remember how many I put back there. 2 through 8. Yeah? Okay, so let's go ahead and use our knowledge of how right triangles work and our trig functions work to start answering some questions. Number 1 says find the exact value. I mean, gives me a fraction. Don't give me a decimal from your calculator. For the trig function indicated. So I don't have to do all 6. I just need to find the one they asked for. And A asked for tangent of theta. So here is theta. I'm going to label my sides. Raise your hand if you know where the hypotenuse in that triangle is. Diana? 11. Very good. It's the longest side opposite the right angle. So hypotenuse. I know my opposite is across from. My adjacent is touching. Good. Good. Set up the ratio. Simplify it. 2 steps. Set up, simplify. Set up, simplify. So tan theta. Juliet, how do I find tangent? What over what? You are Julie and not Juliet, but yes, it's okay. You are correct. Opposite over adjacent. So 4 root 6 over 5. Did I do that correctly? I see some nodding. And I double check. 4 and 5 don't cancel or reduce. I can't simplify root 6 because that's just 2 times 3. None of those are perfect squares. And it's perfect. It's in the numerator, so I'm done. Happy face. Good. Label your triangle. Set up your trig ratio. Check if anything cross cancels, top and bottom. Check if the radical's in the right spot. Check if it can be simplified. Yes, Bruno?
But if it's a function, if it's a square on the bottom, then we get to do it in the front.
Correct. Very good. And I think there's at least 2 of those where you're going to have to do that. Okay. I'm going to pop about 20 minutes on the clock. I want you to do 2 through 8 all the way to a fully simplified fraction. Check with your neighbors. Make sure that everyone at the table is getting the same answer and they know where it's coming from. And at the end of those 20 minutes, we're going to go through those answers together. Sound good? Questions before I set you loose? No. Okay.